Ladies and gentlemen, we're back with some more mathematics. We're on to two-step inequalities. If you didn't watch the previous video on one-step inequalities, make sure to do that first. It's linked down in the description there for you. But two-step inequalities, remember that you have to know a few things when you're doing inequalities. That way you don't mess anything up. Number one, make sure you know which one's less than, which one's greater than. You don't want to flip-flop the inequality symbols. And then remember that there's two important rules that you need to remember for when the inequality sign changes directions. The first one being if the variable is being moved from one side to the other, like the right side to the left side, your sign needs to flip directions. And then the other big one is if you're multiplying or dividing both sides by a negative number, your sign needs to flip as well. So keep those in mind, and let's get into two-step inequalities.
3 years ago, 1 month today, the second left but lost my way, and now I turn through heather walls.
Now for inequalities, again, your goal is to isolate the variable, whether it's on the left side or the right side. Now for this video, we're always going to get the variable on the left side just because it makes students' lives easier when it comes to graphing. That way they don't accidentally graph it the wrong direction. So if we go ahead and look at number one, we have negative 4s plus 20 is greater than or equal to negative 32. I always have my students draw a line right through the inequality symbol separating the left and the right side, because remember, whatever you do to one side of your inequality, you have to do to the other side as well. Then for number one, now we're on to two-step inequalities. You always want to get rid of the number that doesn't have the variable next to it, which always ironically happens to be when you're adding or subtracting the number. In this case is the plus 20. There's no variable next to the 20, so we're going to get rid of that first. Well, how do I get rid of adding by 20? Well, we have to do the inverse, which is step one. Apply inverse operations to isolate the variable. So instead of adding by 20, let's go ahead and subtract both sides by 20, because that's going to eliminate that on the left side and get us closer to isolating that variable. So 20 minus 20, those are inverses or opposites, and we're left with negative 4s is greater than or equal to negative 52. And now we're down to one last step. S still isn't by itself. It's currently being multiplied by negative 4. Well, the only way to get rid of multiplying by negative 4 is to divide both sides by negative 4, which again is the inverse of multiplying. So let's go ahead and divide by negative 4, and then let's make sure we mirror that on the other side of the line as well. Negative 4 divided by negative 4 is 1, so those are going to cancel. And then again, 1 times anything just stays the same, so we're left with just S all by itself. And then we have negative 52 divided by negative 4, which is going to give us a positive 13. And then remember, we just divided both sides by negative. That's one of those rules that you have to remember. If you multiply or divide both sides by a negative number, your inequality sign needs to flip. So instead of it being greater than or equal to, our final answer is going to be S is less than or equal to a positive 13. Now, we talked about in the previous video how to actually graph inequality symbols on a number line, but in case you didn't see that video, if you have the greater than or less than symbols in your final answer, you're going to be graphing with an open circle, which I'll re-explain what that means here in a second. And if you have greater than or equal to or less than or equal to, you're going to be graphing with a closed circle. So for number one, we have less than or equal to, and we're going to be graphing a closed circle at the number 13. So that's going to be right here, closed circle. And then you have to look at the direction the inequality sign is pointing. It looks like the tip of an arrow. So if I just make this a little bit larger to see it better, this looks like the tip of an arrow and it's pointing to the left, which means we're going to go from our closed circle and draw a line down the left side of the number line, and we have our final answer for our inequality, or our graph for our inequality. Now, what does that graph actually mean? If you take any of these numbers that are on this line and plug it in for the variable, in this case, let's pick negative 2 that's on the line. Negative 2, if you plug it in for the variable, it's going to make your inequality true. Negative 2 is definitely less than or equal to the number 13. Now, the closed circle means that 13 can be included as a solution. It means it's going to make the inequality true. So if I plugged in 13 for your variable, this is still going to be an accurate statement. 13 is less than or equal to itself, whereas if it was an open circle, that number does not count as a solution. So this is going to be our final inequality with the correct graph for it for number 1. So now with that explanation done for number 1, number 2, and 3 will go a little bit quicker. So let's go ahead and dive into number 2. So we'll draw a line separating the left and the right side. Again, we want to get x isolated or by itself. So let's get rid of the number that doesn't have the variable. In this case, it's the plus 5. So we want to subtract 5 on both sides. So minus 5, minus 5, 5 minus 5, those are inverses. So those are going to cancel. 12 minus 5 is 7. So it's going to be 7 is less than x divided by 3. And then, well, to get rid of dividing by 3, let's go ahead and multiply both sides by 3 to cancel out that division. So times 3 times 3, these 3's are going to cancel. We're left with 21 is less than x. But again, I always want to get the variable on the left side. So I'm going to move x over here, 21 over here, but that's going to cause our inequality sign to flip direction. So whenever you move from the right side to the left side or left side to the right side, the inequality sign needs to flip. So instead of it being less than, this final answer is going to be x is greater than 21, which means we're going to have an open circle, which means if I plugged in 21 for my variable, 21 is not greater than itself. So that open circle means 21 is not a correct solution. And it's pointing to the right, which means all of these numbers that follow this line are going to be a good solution. So if you plugged in any of them, like 27, 30, 33, whatever, it's going to make your inequality true. And let's go ahead into the last one before you have a couple to try out on your own. This one's a little bit tougher. So we're going to draw a line separating the left and the right side. Let's get rid of the one that doesn't have the variable, which is the minus 4. So let's add 4 to both sides. These are going to cancel. We're left with negative 1/3 x is less than or equal to negative 6. Now, as of right now, negative 1/3 is being multiplied to x. So everyone's first thought is, how about we just do division then? Well, those are inverses. But if you watched a previous video, if you learned about dividing by fractions before, you actually end up doing something different, which is multiplying by the reciprocal to cancel these out instead. So instead of us dividing both sides by negative 1/3, we're going to want to multiply both sides by the reciprocal, which means you're just going to take your fraction and flip the numbers. So we're going to be multiplying both sides by negative 3 over 1, or just negative 3, on the left and the right side. The 3's, which are diagonal from each other, 3 and 3 are both divisible by 3, which is just 1, so those are going to cancel, and same with these ones. So everything's going to cancel on the left side, so you're left with x all by itself, just like we want. Negative 6 times negative 3 is a positive 18, but we do not want to forget we just multiplied by negative 3, which means our sign needs to flip directions, and our final answer is x is greater than or equal to 18, which is going to be a closed circle on 18 with an arrow going to the right because it's just simply pointing that direction. So those are the 3 problems that I have to show you. Let's go ahead and try out 3 problems on your own in the practice session. Well, ladies and gentlemen, it's time. It's time for the practice session. Do you have what it takes to go 3 for 3 after watching our lesson? So I encourage you to pause the video, try out all 3 questions on your own, just on a scratch piece of paper, and when you think you have all the correct answers with the correct graphs, play the video and let's see how you did. So I'm assuming at this point you've tried out all 3 of them and you're ready to go over the answer. So let's go ahead and look at number 1. First, we're going to draw that line separating the left and the right side. We want to get rid of the adding by 20 by subtracting 20 on both sides. So minus 20, minus 20. These are inverses, so those are going to cancel. We're left with negative 7x is less than 14. And then negative 7 is currently being multiplied. Well, let's get rid of it by dividing by negative 7. Negative 7 divided by negative 7 is 1, so those are going to cancel. We have x all by itself. 14 divided by negative 7 is negative 2. We did divide both sides by a negative, so hopefully you caught that the sign needed to flip there, and your final answer should have been x is greater than negative 2. Now for your graph, you should have a open circle, because it's not an equal to, and it is pointing to the right, which means our arrow should be going this way, and this should be our final answer for the first one. So if you got this one right, very, very nice job, and let's go ahead and move on over to number 2. Again, draw our line. We're getting rid of the minus 8 by adding 8 on both sides. 8's cancel, those are inverses, and we have 10 plus 8, that's 18, is greater than 2/3 s. This is very, very similar to what we just did in number 3 in the regular lesson. We need to multiply both sides by the reciprocal this time around. So we're going to multiply both sides by 3 over 2, so times 3 over 2. The 3's are going to cancel over here, the 2's over here are going to cancel, and then 18 times 3 over 2 is going to give us 27. So we're left with 27 is greater than s. The inequality sign did not need to flip here, though, because we didn't multiply the sides by a negative. But it does need to flip, though, because s is on the right and I want it on the left. So s is here, 27 is here, but it's going to be s is less than 27. So open circle on 27 with a arrow going all the way down the number line for our inequality graph for number 2. So if you got that right, very, very nice job. And let's go ahead and move on to the last one. So drawing our line once again, let's subtract 2. So minus 2, minus 2. 2 minus 2 is 0. That goes away. We're left with w divided by 4 is less than or equal to negative 6. W is being divided by 4, so we want to multiply both sides by 4. So times 4 times 4. The 4's are going to cancel, and we are left with W is less than or equal to negative 24. We did not multiply both sides by negative, so nothing needs to be flipped here at all. So we're going to have a closed circle this time on negative 24, and it is going to the left. If you went 3 for 3 on this, very, very nice job. Hopefully this video helped you out on two-step inequalities. But we'll see you in the next one with some more mathematics.